So practice test for 7.3 to 7.6. Again, Google Meters, that is in the black file labeled digital copies, and we need the one that says 7.3 to 7.6. The one I had in the handouts was 7.3 to 7.5. So we'll need to, actually you could probably just use that one and then write the couple of extra problems on from 7.6 and you'll be fine. So this is going to be a half sheet. And what we'll do on Monday is everybody will take their calculators out and put them underneath their desk. And you'll take this portion of the test, which is no calculator allowed, but you'll have a power sheet. I'm not handing out power sheets today because if I give them to you today, I don't have enough to also give them to everybody on Monday. So we'll do this without the power charts, but you will have those on Monday for the test. Then when you're done with that portion, you'll bring up the little half sheet, and I'll trade you. I'll give you the rest of the test that you can use the calculator on. So away we go. Evaluate each logarithm, not allowed to use a calculator. Obviously, you have to show your work so that I can see how you figured all of this out. So looking at number 1, I wonder, you probably can do that one without having to do a lot of work, right?
Yeah.
What is it? Snail shell it? What do you get? Yeah. But see, even this, just doing this and writing 3 to the x equals 27 tells me you knew what you were doing. You know, that's the step I need to see. And then if you accidentally write 4, you know, I can still give you something on that problem, give you half a point because you were okay until you got there, because it's 3 to the 3rd. So when it says evaluate, we're trying to work it down as far as we possibly can. Well, this is kind of goofy. The little fraction lines disappeared. Again, we'll start that way, and we'll snail shell. Now, here's a really important step. If it goes from fraction to no fraction, or no fraction to fraction, that meant they had to raise it to what power? A negative power, yeah, because that's what flips it. But this doesn't need a negative, because it's still a fraction. So all we have to figure out is, what do you raise 1 to get 1, and 3 to get 81? That's what we have to do. Now the 1 we don't have to spend a lot of time on, because 1 to any power is 1. But 3 to some power is 81. What's that power? 4. Done. 1 to the 4th is 1. 3 to the 4th is 81. Again, the only time you're using negatives if it goes from not a fraction to a fraction, or fraction to not a fraction. All right, number 3. We set it up. We snail shell. And this one you'd probably use the power chart for. We didn't get to those powers of 4 very often. Anybody have it already? It is 4. It's the 4th power. Again, you'll have a power chart on Monday. All right. Those little lines show up on my computer screen. I wonder why they don't show up here. Equals x, 64, whoops. And here I am starting to put the 4 up as a power. All right. Not a fraction to a fraction. So what do we absolutely know happened? Right. But this one, we might want to go a little bit different. This one, we might want to think about equating the bases. 64 and 8. We had a really small number on the power chart that would get 64 and 8. 2, yeah. So we'll think about this one for a second, but I know that you all know this is 2 to the 3rd because we've seen that a ton of times. So you sit and think for a minute. Let's see, 2 to the 1st is 2, 2 squared is 4, 2 to the 3rd is 8, to the 4th is 16, to the 5th is 32, and then 32 times 2 is 64, 6. So now I multiply the 6 and the x, and here's where I realize, well, I could just write that as 2 to the negative 3, because that's the reciprocal, 1 over 2 to the 3rd. What did we do with that at this point? Yeah, drop the big 2's. Don't need the big 2's. They're already equal. So we really just need to solve that. -1/2. Phones down, or I'm going to take them. This is a really important test. It's 7.3 to 7.6 is going to be weighted more than some of the other tests we took because it has more sections in it. Now, if you could have figured that out without going through all this equating the base stuff, that's fine, as long as you can show me how you got it. It can't be a guess and check thing. You have to think your way through it algebraically. Alrighty, let's try this one. So before we get started, what do we absolutely know is going to be a part of this answer? Has to be a negative. We're going from fraction to not a fraction. Do you want to do this one the same way we just did number 4? Or not? Got something else in mind? So some of you are just doing it in your head and saying, okay, well, we just got done with 64, and that was to the 6th power. Back that up 1, and you have 32, so it'd be -5. Again, to show work, you'd probably want to do the equating the basis thing. Otherwise, you're going to have to write me a little sentence. You know, if you can look at that and go, boom, it's -5, then you have to tell me, I saw that it went from a fraction to not a fraction, and I know that 2 to the 5th is 32. You know, little things like that. Now 6, I don't want you to overthink. 6, we should just be able to look at and say, it's 7. Yeah, it's 7. Notice the bases match. Logarithm base and the base for the exponent are the same. These are inverses. So once you're done and you've double checked all of that with your power chart and everything, you'll just bring that little half slip up to me, and you're going to get something that's going to look like the rest of the test here. And we know all the points come from the steps where you're showing your work, so make sure you show your work. Taking a look at number 7. I know I have to get that base of 4 right in the front so that I can get rid of it, but there's other stuff over there. So what do I do? Subtract 12 from both sides. Can that negative be there? No. No. So how do we get rid of it? We're going to divide both sides by -1 so we can expose that base of 4. Now you're allowed to use a calculator at this point. Some of you might say I don't need to, but it's the third. It's the third. So yeah, you could do equating bases at this time, or you could look at your power chart, or you could just putz around on your calculator. 4 to the 2nd is 16. Hey, wait a minute. 16 times 4 is 64. That's going to be 3. Now, if you wanted to, you could take logarithms of both sides and use the change of base formula on your calculator. So there's all kinds of things you could do. You just have to show me what you're doing. So how many of you would be jumping to x equals 3 at that point and just writing down x equals 3? Okay, those that aren't, remember at this point you can take logarithm base 4 of both sides. This will drop out, and you can use the change of base formula on your calculator. You're still going to get 3 either way. So lots of choices. Take a look at number 8. That does not look ready to go. What do we need to do? We got to take care of that subtraction. What's subtraction in logarithm language? Division. So we're condensing it. Now we don't want log in our answer, right? How do we get it so there's no log anymore? Yes, we snail shell. What's the base of this little puppy? Yeah, If it says log, that's base 10. So 10 to the third equals 500 over x. 10 to the third happens to be 1,000. Lots of different ways to solve from there. Anybody going to slap a 1 under it and cross multiply? Yeah, I'd probably do that too. So 1,000x equals 500. You divide both sides by 1,000, and x equals 1/2. Now, both of these that we just did, totally checkable. All of these. Every single one on this test. Check it. The condense and expand would be a little harder to check, but these are actually going to come out as numerical answers on your calculator. All right, take a look at number 9. What do you want to do? No, I'll put that away. Snail shell. Looks good. Do we know what 3 to the 4th is? Add 7 to both sides. Again, totally checkable. Plug it in there. We could use the change of base formula on our calculator. All kinds of different things we could do. Number 10 comes from yesterday's stuff. I don't like that my blue is kind of running into that. Let me rewrite it. We have to expose the base. Is the base the first thing we see? Then we have to figure out how to get rid of the 3. Divide. Divide both sides by 3. Now, if the base is e, and we have to take logarithms of both sides to solve it, what kind of logarithm are we going to take? Yeah, ln, natural logarithm, because those are inverses, and they're going to cancel right out. And natural log of 8 is something we can press in on our calculator, but we're going to go ahead and write down that we know we have to also divide it by 2. And then we'll go get our 4 decimal places. Natural log of 8 divided by 2. And don't forget to finish up the parentheses for natural log, or you are not going to get the right answer. Remember, those parentheses are really important. 1.0397. And remember with that one, if you want to check your answer, it'll be close to 24. I mean, if you're going to use those 4 decimal places, it'll be close. Won't be exact, but it'll be really close. Number 11. What you thinking? Yeah. Subtract the 6. Divide by negative 3. Exactly. Snail shell with a base of e. That's the number our calculator is going to kick out for us right there. I mean, if you wanted to make an extra step out of it, you could certainly write it as 1 over e, but you don't have to. It's a calculator thing. Second e to the negative 1 power. 0.3679. Again, if you check that one, if you use your 4 decimal places right there, it's going to be a little bit off, but it'll be really, really close. So far, so good? Okay, just remember, natural logarithm is logarithm base e. So if we need to get rid of e, we're going to use natural logarithm. And if we have to get rid of ln, we have to snail shell with a base of e. Alrighty, we're at number 12 already? Wowzers. Oh, this was one of the first things we did with logarithms. You guys said this was a piece of cake, but this is always hard when you come back to it a week and a half afterwards. So we want to know, what did this look like before it became 11 to the third equals 1,331? So think backwards. Log, what was the base? base 11, and that needs to be a subscript, so smaller and a little bit below it. Then do your unsnail shelling, 11 to the third. Now, this is important because you will lose like half a point if you do this. Notice the 1,331 and the 3. My 3 is actually a little too big. Those should be the same size. This 11 has to be smaller because it's supposed to be a subscript. So don't make them all look like they're all the same size. Matthew. Quarter of a point, you know, but it has to be something because these are not all the same with logarithms. Alrighty, so 13. That should make 13 go a little easier, right? Log base 5 on the other side of the equals. And again, your 0.008 and your -3 should look like they're the same size. Your 5 should be a little smaller, a little subscript. I can't write it small up here, or people in the back won't be able to see it. Well, that's a weird one, 14. But I think we can do it. Log base x over to the right side. And then I'd probably put that in parentheses because it's a fraction. Make sure everybody knows that goes together. John, put the phone away. That's 14 of them. Not if it's clear that it's a fraction and it's in the position that you're evaluating that. Sometimes it's a real struggle because people will do stuff like this. And that I can't give full points for, you know, because it doesn't look like this is a base anymore. It's kind of up there in no man's land. So just be careful when you write those. They're not the hardest things in the world, right? So just slow down a little bit, you know, make sure you're writing those correctly. Now, these are the ones I was talking about where, you know, you probably can't check these with the graphing calculator, but you could go back and check and see that it matches. Here's a test-taking strategy. I want everybody to look at, and I'm going to get my glasses on here, 15, 16, and 17, and then look on the next page, 18 and 19. That's a test-taking strategy because you realize, well, this is what it starts looking like in 15, 16, and 17, but this is what it's supposed to finish looking like in 18 and 19. And when you do it backwards, 18 and 19 should look like 15, 16, and 17 when you're done. So use that test-taking strategy of looking forward and looking backwards. All right, 15. We're writing each as a single logarithm, also known as condense. What do you see? Okay, 2 can't be there. Where's it go? Yes, that's going to be our 3 squared right there. And some of you might immediately say, oh, that's 9, and just skip that step. Oh, my G doesn't look very good. Not done yet, though, because it's not a single logarithm. What's left? Good. There it is. You know what? This one you could check. Somebody let me know why would that one be checkable. Does our calculator do logarithm base 10? It sure does. So this one you could punch this in just as it is and then punch log of 7/9 and see if it comes out to be exactly the same thing. 16. What do you see? Just subtraction is division, right? All right, let's see what happens. I don't think we're done with that one. What do you notice? Yeah, so we're going to get ourselves a nice 1 up here on the top. Parentheses are not for this one because it's a base of 10. Notice how the base wouldn't be anything you would mistake for any of those. So you wouldn't have to use parentheses for either one of those with base of 10. All right, 17 looks tougher. fact, I can barely read that. Base of 3 show up pretty good on your copy? Okay, good. Order of operations says we have to do parentheses first. That's what we should do first. So what's going on inside there? They're becoming multiplication. Now, I look at 18 and 19 and I see, oh, there's no 1/2 power there. But there is how to convert it. 1/2 power is the same as what? It is the square root. So we'd put it back up, but then we'd look at 18 and 19 and say, oh, I know what that is. That's square root. Oh, I left my 3 off. Thank you. The other 2 were log 10, so I just kind of ignored it. And I can't see the 3 very good up here. All right. So far, so good? So now let's think backwards, because now we're going to expand. So what are you thinking for 18? Got some multiplication? What else? Oh, for 18? Oh, go ahead and write this one down. Write this one down. Logarithm base 3, 4x to the 3rd over y squared. I caught one of the other ones that was different, but I didn't catch that one. Oh, interesting. All right. Okay, so how about we just go top to bottom and do the whole thing? Not at once, though. Let's not take care of the powers right away. What's going on up here? Addition, because it's multiplication. And then we have the subtraction. Again, I have to write my 3 bigger up here because I want everybody to be able to see it. So, still not done. What do we have to do? Bring those powers forward. Now, we could be thinking at the same time, is logarithm base 3 of 4 something nice that we should know? 3 to the something is 4? Nah. Logarithm base 3 of 4 plus 3 logarithm base 3 of x minus 2 logarithm base 3 of y. Is that everything we can do? And again, you could look back at 15, 16, and 17 and see, is that how this all started out? Now, looking at the one you had, pardon me, Emma, yours was logarithm base 2 with a 4. Bless you. So, before I had you change it, this would have been one that should have caught your eye, right? What does that say? It says 2. So this one, if you snail shell it, 2 to the something is 4. This needs to be converted to 2. So watch for those. Like I said, when we got here, stop and think, is this something that I could convert, something that's going to be nice? Number 19. Take a peek. What are you thinking? When 2 things are sitting right next to each other in algebra, what's that mean? Multiplying. And what's multiplying in logarithm language? Adding. All right, I should have known better than to grab the blue. Thoughts at that step? It is a 2, yeah. 3 squared is 9. Now, 16, 17, and 18. Did they have any square roots in them? So we have to figure out how to redo that. Square root is what power? And if it's a power, can we leave it there? Has to go in front of this term, not the whole thing. And now we've got it. So again, test-taking strategies, use those. Condense and expand are opposites of each other. Use that to your advantage. Unfortunately, the Google meters don't get that advantage because they get one problem at a time. All right, number 20. Use the change of base formula to evaluate each expression using common logarithms, round to 4 decimal places. What would we be punching in? Exactly, and you have to write that down because the instruction said use the change of base formula. That shows me you know what the change of base formula is, and then you punch in. Again, being very careful to put parentheses behind the 8. Oh, and I just forgot. Was it a 2? 3. Thank you. 1.8928 with rounding. So far, so good? Now, do you remember graphing? It was super easy, so boom, it's gone, right? I mean, it was too long ago, and it was so easy, and you guys were ripping through it while we were doing the notes, and now it's like, oh, it's all gone. Graph each function, showing the parent function and then the translation. Graph asymptotes. Use at least 3 points from your table. Well, it looks like this right now. And we don't know how to graph that. So how could we get a different form so we'll know what we're doing? Snail shell. Snail shell. 3 to the y equals x. Remember, these are such pure inverses that they literally switch the functions of x and y. Now we have y that we're going to put in. And we didn't put in what kind of numbers? No negatives. We were always going to do positive bases. So they said we have to have at least 3. There's some good ones. 0, 1, and 2. 3 to the 0 power is 3 to the first, 3 squared. Now, they also said we're supposed to graph it and then graph its translation. Does this one have an h or a k or both? So it's going to be its own parent function. We're not going to have 2 graphs on this one. But that brings us to the, do we remember where the asymptote is? The y-axis, which has a math name of x equals 0. So that is our asymptote. And let's go ahead and put our little points on here. About like so. And I graph this because I was tricky. And I remembered I can use the change of base formula to graph this on my graphing calculator now. I'm going to punch in log of x over log of 3 and let my calculator do this whole thing. And I lose points because it stops. That's grapher error. The graph does not stop. We know what an asymptote does. It's going forever down there. We have to know that. Don't use your graphing calculator for these. These are not difficult. You just have to remember where those asymptotes are going to be. So domain does not appear we're using all the x's. X is greater than 0. Range, up and downers? Yes, that one's all reals. Again, this one didn't require a translation, so we didn't have to have a parent and then our moved graph. but this one will. Graph each function, showing the parent function, and then the translation. Graph asymptotes. Use at least 3 points for your table. So what do I ignore for my parent function? The +2. Yeah, we're going to take care of that when we do our counting this way, that way, whatever you guys decide it is. So I just want this right now. Hey, wait a minute. There's no base. It is 10. LOG is base 10. 10 to the y equals x. Again, I'd just pick 0, 1, and 2. 3 nice basic points. 10 to the 0. 10 to the first. 10 squared, which we're not going to graph, but they said we have to have 3 points, so, you know, gives us a good thing to aim at. Now, this is the parent, and it has an asymptote at the y-axis, but it's going to be dashed or dotted. Actually, I've got 2 little points here. I maybe better put a halfway or something in there so I can know where that's at. All right. So now comes the big move. Where's it going to go? 2 to the left. So what is really important for us to move before we move our points? The asymptote, which is, of course, going to be at x equals -2. And then we can just take our little points and move them 2 to the left. Domain? X is greater than -2. Range? So definitely a good thing we reviewed, because remember, that graphing, that was so slick back when we did it, and now it's just been too long. Well, that's the end of it. Excellent. We have a little bit of time here. Any of these you want me to come up with another example of for us to run through?
Will there be anything for these graphing ones to move it up and down, or just be left and right buttons?
That I can't tell you. You might see one that just has the right and left shift. You might see one that just has the up or down shift. And you might see one that has both. All depends on what version of the test you're getting. So we try to be fair with that. You know, like I mentioned, the Google Meters, they only get 1 problem per page, so they can't use that test-taking strategy. So we give them something a little bit different that's a little bit easier on another problem than what you have to try to take care of that. All right. Well, tomorrow you can rewatch the practice test all you want, but what you really need to do is you need to get some practice on this. So this is the assignment, and because there weren't very good evaluates without a calculator, condense and expand, that we hadn't already done as part of our assignment before, I had to make up a couple and put them on there. This is also in that black digital folder that says, you know, copies of all the handouts and all that good stuff. And it was in your, I believe, yes, it absolutely was in the stuff I gave you at the beginning of the semester. So you do have a little slip that has all these on there too.